Hello everyone. So in today's video of chapter Thermodynamics, I'll be talking about enthalpies. Enthalpies of physical transformations. In this heading, we'll be learning enthalpy of physical transition and enthalpy for atomic or molecular change. Enthalpy of physical transition. In physical transition, one phase of a substance is converted into another at constant temperature and pressure without changing in its chemical composition. So the first enthalpy, and that is enthalpy of fusion. Enthalpy of fusion is enthalpy change that occurs when one mole of solid is converted into liquid without change in temperature at constant pressure. For example, when 1 mole of solid ice is melting at 0 degrees Celsius at 1 atmospheric pressure, the change in enthalpy is 6.01 kilojoule per mole, and the same amount of heat is absorbed by ice during melting. A reverse of fusion is freezing of solid. That means liquid is converting into solid, and when solid is formed by liquid water, this delta H will be called as delta freeze H, and its sign would be reversed and it would be minus 6.01 kilojoule per mole. Now enthalpy of vaporization, denoted by delta Vap capital H. It is enthalpy change accompanying the vaporization of 1 mole of liquid without changing its temperature at constant pressure. When 1 mole of water is vaporized at 1 atmospheric pressure, the enthalpy change is 40 kilojoule per mole at 100 degrees Celsius. Whereas when water is vaporized into gaseous state at 25 degrees Celsius, the delta Vap H is equal to 44 kilojoule per mole. On the other hand, the condensation of vapor is accompanied with release of heat. You can say when gaseous water is turning up into liquid water, delta con capital H would be minus 40.7 kilojoule at 100 degree Celsius. Now, next is enthalpy of sublimation. Enthalpy of sublimation is the enthalpy change for the conversion of 1 mole of solid directly to vapor at constant temperature and pressure. Means when solid water is converted into gaseous water, delta sub H is equal to 51.08 kilojoule per mole at 0 degrees Celsius. The conversion of solid to vapor occurs in one or two steps. First, melting of solid into liquid, and then liquid's vaporization into gas. Enthalpy change is the same, since enthalpy is the state function at 0 degrees Celsius. First, when solid is turning up into liquid, delta fuse H is equal to 6.01 kilojoule per mole. And when liquid is turning up into gas, delta Vap capital H is equal to 45.07 kilojoule per mole. And on adding these two values, we will be getting delta sub H is equal to 51.08 kilojoule per mole. Here it is representing delta sub is actually equal to delta fuse plus delta Vap H, and the summation of these two will be getting delta sub H. Now, enthalpy for atomic or molecular change. Enthalpy of ionization or delta INH. It is the enthalpy of change accompanying the removal of electron from 1 mole of gaseous atom. For example, sodium in gaseous state is removing its 1 electron to form gaseous sodium ion, and here the enthalpy change would be 494 kilojoule per mole. Now, if any atom is gaining electron, then the electron gain enthalpy gives the enthalpy change when 1 mole of gas phase of atom of an element accept electron to form gaseous anion, where example like chlorine in a gaseous state, chlorine atom is accepting 1 electron to form chloride ion, where the enthalpy change would be minus 349 kilojoule per mole. Next is enthalpy of atomization, delta atom H. At the enthalpy change accompanying the dissociation of 1 mole of gaseous substance into atoms, like chlorine molecule which is gaseous, it is turning up into chlorine atoms. Enthalpy change would be 242 kilojoule. Or methane is turning up into carbon and hydrogen. Enthalpy of atomization would be 1660 kilojoule per mole. Now enthalpy of solution. Enthalpy of solution is the enthalpy change in the process when 1 mole of substance dissolved in specified amount of solvent. For example, sodium chloride is dissolving in water to give you aqueous sodium chloride. Its solution enthalpy change would be 4 kilojoule per mole. Enthalpy of solution at infinite dilution, the enthalpy change when 1 mole of substance is dissolved in infinite number or infinite amount of solvent. It used to happen in 2 steps for ionic compound. In first step, the ions separated from the molecule. Like if a salt is Mx, which is solid, it will give you M ion and X ion, or you can say cation or anion. In this enthalpy change, we will say the enthalpy is crystal lattice enthalpy, which is denoted by delta LH, which is always positive. In the second step, the formed ion will be hydrated and surrounded by the water molecules like this. And the enthalpy change for this step is always negative, and this is called enthalpy of hydration. Delta hyd capital H. And the enthalpy of solution is the sum of crystal lattice enthalpy and enthalpy of hydration. In this way, we will get to know the enthalpy solution, that is delta solution H is equal to delta LH plus delta hyd H. And on summation of both the values, we will get the enthalpy of solution.